All right, so today we'll look at section 2.4, and that's the only section we're going to do for today. And it's on solving linear inequalities. Today we'll focus on linear inequalities, and then tomorrow we're going to look at higher order inequalities. Like we've done quadratic equations. We can also do quadratic inequalities, but we'll save those for tomorrow. Okay, so those are our four basic inequality symbols. Less than or equal to, greater than or equal to. Okay, and these are all examples, or both of these are examples of inequalities. Okay, the first one is just a true statement. The second one is a conditional inequality. It's true if you pick the right values for x. And what's different about a conditional inequality is there's infinitely many answers that make that true. Okay. Versus usually when you have I'll put the x in the middle, but what could I switch?
Where are the 3?
Okay, so I could put the 3 on this side, the -1 on this side.
And now put your symbols the other way.
Yeah, this is the same thing. This is saying x is less than 3 and x is greater than -1. Okay, so either way, I usually do the way on the left. But if you want to do the one in green on the right, you can do that too. Okay, so this particular inequality, all the answers form what's called an interval. Okay, it's a range of numbers between -1 and 3. Okay, and this is called an open interval. Okay, so we've talked about open versus closed. Can anybody tell me what makes this interval open? Allie? Yeah, we don't have the equal to's. Okay, so an open interval means you can pick numbers strictly between -1 and 3, not included -1 and 3. Okay, so any questions on that? All right, so we're going to talk about a few different words today. We're going to see open intervals, we're going to see closed intervals, and then we're also going to see a bounded interval and unbounded intervals. Okay, bounded intervals mean that you have an interval where the bounds are actually numbers. The lower limit and the upper limit are both numbers. Can anybody think of a time when you have an interval where either the lower limit or the upper limit is not a number? We've had intervals like this before. Well, Andrew, can you think of a time when you have an interval where one of either your lower limit or your upper limit is not a number?
No idea.
Not sure. Zach?
It's infinity.
Yeah, when it's infinity. Okay, infinity is not a bounded interval. Okay, that's not a number. Okay, so when we get to unbounded intervals, we'll see that's where infinity comes up. Okay, so the 4 types of bounded intervals you can have. You can have an interval that's fully closed, okay, closed on the left, closed on the right. Okay, you can have an interval that's fully open, okay, open on the left, open on the right. And then you can have a half-open interval, or half-closed if you're pessimistic. All right. But the idea is that one side is open, one side is closed. And the way you could distinguish it if you wanted to pronounce it to somebody is you could say it's half open on the right or half open on the left. Okay, and those intervals would correspond to having less than or greater than or equal to's. Okay, equal to's give you the closed interval. Strictly less than or greater than, that's where you get open intervals. In page 99, I think they go through different examples, and they show you it with numbers, and then they show you like graphing it, how it would look on a number line. Okay, when we graph on a number line, we can either use open circles or closed circles, or you can use a parenthesis and a bracket. Okay, when you use a closed circle, what symbol corresponds to closed circles? Parentheses or bracket? David?
Bracket.
Bracket. When you use an open circle, the symbol that corresponds with that is
Parentheses.
parenthesis. So just don't mix them. Either use the circles or use brackets and parentheses. All right, so if we have bounded intervals, I said we can also have unbounded intervals. And that's where either the lower limit or the upper limit is not a number. Okay, it's unbounded. Okay, so question on unbounded intervals. Could I have an interval that's completely closed and unbounded? What do you think? Trevor? No. Closed means you have the bracket. Bracket means that you can reach that number. Okay, you would never have brackets on infinity. All right, so those are really the only types of unbounded intervals you can have. You can have unbounded on the left, and then open or closed on the right. Or you can have unbounded on the right, and then open or closed on the left. But it would be impossible to have a completely closed, unbounded interval. That doesn't make sense. Okay, and if you want to see some more diagrams and basically what I have right above it, page 100 in your book, it's got some diagrams there. Okay, so we're going to just practice kind of translating between an interval and an inequality. All right, so they're giving me an interval here. Who can tell me what kind of interval is that? Using the words we just learned. Open, closed, bounded, unbounded. What is that? What, Amanda?
Half open, bounded.
Yep, it's half open, specifically on the left, and it is bounded. Okay, the lower and the upper limits are numbers. Right, so can somebody tell me how I would write this as a conjunction? Okay, specifically with x in the middle. Okay, I don't want to write two separate conjunctions. About Kayla?
-3 is less than x is less than 5.
-3 is less than x, and can you keep going?
Is less than 5.
Like that? All right. Just about just one thing there I need to change. That's small change, but it's important. Yep.
It would be less than or equal to 5.
Less than or equal. Okay, remember, because that's a bracket. You just have to put in that equal to. But yep, that's it. Okay, questions on that one? All right, let's try this one. Okay, first I'm just going to ask what kind of interval is it. So Rachel, can you tell me what kind of interval this is?
It's an unbounded half.
Yep, it's unbounded, okay, because we have infinity in there. And this one is half open on the right. If it's unbounded, it has to be either half open or fully open. It cannot be closed. Okay, we already said that. And Francisco, can you tell me how I would write this as an inequality? And you could use x as your variable.
Greater than x. Less than, less than, before the x, it's less than 4.
For the x, less than 4?
Yeah.
All right.
Then less than
And then another less than? Okay.
Infinity.
Infinity. All right. Any thoughts on that one? Or if you think it's fine, just tell me you think it's fine. Yeah, Joe.
I think you need a less than or equal to.
Okay, I think we definitely need the less than or equal to because that's a bracket, not a parenthesis. All right. So technically now this is fine. Okay, I would accept that. But I think we could write that even a little simpler. There's more we've written here than we really need to. Yeah?
Could you just write -4 is less than or equal to x?
Yeah, you could just write this. Or if you had it like this, x is greater than or equal to -4. That's all you really need. You can pick any number from -4, including it, and up. Okay, so this one isn't really a conjunction. You could just write it like that. Okay, questions on that one? Okay, just make sure, especially if you're writing the other way, from an inequality to an interval, smaller numbers up like that. All right. Just about just one thing there I need to change. That's small change, but it's important. Yep.
It would be less than or equal to.
Less than or equal. Okay, remember, because that's a bracket. You just have to put in that equal to. But yep, that's it. Okay, questions on that one? All right, let's try this one. Okay, first I'm just going to ask what kind of interval is it? So Rachel, can you tell me what kind of interval this is?
It's an unbounded interval.
Yep, it's unbounded, okay, because we have infinity in there. And this one is half open on the right. If it's unbounded, it has to be either half open or fully open. It cannot be closed. And we already said that. And Francisco, can you tell me how I would write this as an inequality? And you could use x as your variable.
-4 is greater than x. Less than less than before the x it's less than 4.
For the x, less than 4?
Yeah.
All right.
And less than after.
And then another less than? Okay.
Infinity.
Infinity. All right. Any thoughts on that one? Or if you think it's fine, just tell me you think it's fine. Yeah, Joe.
I think you need a less than or equal to.
Okay, I think we definitely need the less than or equal to because that's a bracket, not a parenthesis. All right. So technically now this is fine. Okay, I would accept that. But I think we could write that even a little simpler. There's more we've written here than we really need to. Yeah?
Could you just write -4 is less than or equal to x?
Yeah, you could just write this. Or if you had it like this, x is greater than or equal to -4. That's all you really need. You can pick any number from -4, including it, and up. Okay, so this one isn't really a conjunction. You could just write it like that. Okay, questions on that one? Okay, just make sure, especially if you're writing the other way, from an inequality to an interval, smaller numbers always on the left, bigger numbers always on the right, or bigger idea, okay, is on the right. Okay, so now we have a bounded closed interval. Okay, when I said that, was there anything redundant? I said it's a bounded closed interval. Could I have said that in a simpler way? Yeah.
You could have just said it's a closed interval because unbounded ones can't be completely closed.
Right. I could have just said that that's a closed interval. If it's closed, it means it doesn't have infinity because you can't reach infinity. Right? So saying it's a closed interval automatically means bounded. All right, so now I want to write that one. This one is going to be a conjunction. Right? How do I write this one, Amanda?
-8 is less than or equal to x is less than or equal to -3.
Yep. And so again, that one you do need the conjunction because you have a bound on each end that you have to stay between. Okay, any questions on that one? All right. Okay, so let's do some graphs. Okay, we'll graph x is greater than or equal to 2. All right, so what do I have to do to graph that? What's the first thing I have to do? Rachel? Yeah, I gotta put a point at 2, and I really need to number my number line because I don't even know where 2 is right now. So I'll just put 0, 1, 2. You don't have to number the whole thing, just number a few so I know where we're at and what the scale is. Okay, and what would I put on the 2? What are my choices? 2 choices. David?
Either a bracket or a closed circle.
Yeah, either the bracket or the closed circle. Since we've been using the brackets and parentheses, I'm gonna stick with that. The only thing is, if I put a bracket, I have to already know which way I'm going to shade. With a circle, you don't. Okay, so if I put the bracket, which way am I going to be shading? To the, Trevor?
To the right.
Yeah, I'm going to be shading to the right. So put your bracket facing right. All right, let's look at B. Okay, so this one says x is less than 5. Okay, Ava, what kind of symbol do I need on 5?
You need a parenthesis
Yeah, I can do a parenthesis. And which way am I going to shade?
to the left.
To the left. I want all x's less than 5. Now, can you always just go by the direction the inequality points? In the last 2 we did, but can you always do that, David?
If your variable is on the left side.
Yes, only if your variable is on the left side. Okay? If you had a problem, 5 is greater than x, that's exactly the same thing. But I think it's confusing when you put the variable on the right because then the symbol doesn't tell you which way to shade. Okay? So we'll stick with keeping the variable on the left. Unless we have a case where the variable is in the middle, then you have to write it this way. So I've got -1, 0, 1, 2, 3. Okay, how about Alyssa? What kind of symbol on -1? Yep, bracket. Pacey, what kind of symbol on the 3?
Parentheses.
Parentheses. And where am I basically shading in this one? In between. Okay, so bracket, parenthesis, shade between. Okay. Questions on that one? Right, so you should be familiar with how to take either an interval and graph it, take an inequality and graph it, look at a graph and work backwards to get the inequality. Right, so if I gave you this picture, you should be able to figure out that. Okay, so all kinds of variations with those problems. All right, so when we're solving an inequality, we basically use the same step as when you solve an equation. But what's different? One thing that is a little bit different with inequalities. Yeah?
The thing is, if you divide a negative over the inequality sign, you flip it.
All right, so it's, if you divide or what else?
Just multiply.
Or multiply. Okay, if you do either multiply or divide each side by a negative, then you have to flip the inequality. Okay, that's the only thing that's different. Okay, don't forget to flip the inequality. All right, so let's try to solve this one. They don't ask us to graph it, so we don't have to graph the answer. We just have to show the steps to solve it. Right, so Taylor, what would be my first step in solving that inequality?
Distribute the 3.
Yeah, just like an equation, we're going to distribute out the 3. And sometimes we can do more than one step, but we'll hold off. We'll just do one step at a time. All right, so we distribute out our 3. Okay, what do I do next? About Tom?
They would combine like terms.
Yeah, combine like terms. What are your like terms?
-3 and 2.
Yep. And what do you get when you combine those? Yep, -1. And now we're at the step where we're basically going to decide whether or not we have to use this rule. Okay, we can avoid using this rule if we rearrange this correctly. If not, then we'll just use the rule. All right, so Andrew, what would I do next?
Get all the x's and all the numbers on the
Sure.
opposite sides.
Yep, so how do I do it?
Subtract 3x and then subtract 6.
Yep, so subtract 3x, subtract 6. 6's are gone, 3x's are gone. And Allie, what's -1 minus 6? -7, less than or equal to 5x minus 3x. 2x. Now, am I going to have to use that rule where I flip it? Nope, because I'm not going to be dividing by a negative. But how come there's a negative on the other side? So why don't I flip it because of that?
Because you're not multiplying or dividing by it?
Yeah, I didn't multiply or divide by the negative. Right? That's just hanging out on the other side. There's really nothing I need to worry about with that as far as flipping. Okay, so what's my final answer? And I'd like it with the variable on the left.
X is greater than or equal to -7.
Yep. Let's see. Okay, x is greater than or equal to -7/2. Okay, questions on that? All right, so let's look at how we can solve an inequality with the graphing calculator. There's really two ways. Okay, one way you can do it is get the inequality equal to 0. Okay, calculate the root. But now the root isn't your answer. Okay, it's everything from that root above it, or it could be everything from that root below it. It depends on if it's a greater than or a less than. So we'll look at doing it this way to start. Keep in mind, sometimes you include your root, sometimes you don't. It depends on if it's the equal to or if it's not equal to. All right, so let's try method 1 on this inequality. So step 1 is to get 0 on one side of that inequality. Okay, if you don't have your graphing calculator, that's okay. You don't need it. We're not doing anything you haven't done before. We're just going to find a root. All right, so Trevor, how would I get 0 on one side of example 4?
Subtract 2.
Yeah, I'd say that's the fastest way. Subtract 2, and that's going to give me 4x minus 3. Okay, so there's my inequality. Okay. Now, I guess one step I could put in here, before you can calculate the root, you got to graph it. Okay, so let's type this in. Just type it in as 4x minus 3. You're not going to be able to change this from an equal sign in y1. All right, so just type it in as y1 equals 4x minus 3. And resume 6. Okay, so we've got our line. And let's see. So now we want to know where this is less than 0. Okay, I want to know where that blue line is below the x-axis. So what I want to do is calculate right where it crosses. Okay, that's my root. My 0. Find the root. It's 0.75. So now that I know my root, what is my answer? Amanda? Well, think about, what do you want to happen in this inequality? When you plug in values for x, you want it to come out to what? Less than 0.
So it'd be anything less than 0.75.
Yeah, if you plug in numbers to the left of 0.75, look at where you're going to be. You're going to be below the x-axis. Okay, and that's what you want, less than 0. Okay? In this case, do I include 0.75 or should I don't include it? Yeah, we don't include it because it's strictly less than. Right, so how about Quinn? How would I write that as an interval?
It's parentheses.
Yep.
Negative infinity.
Yeah, good. Negative infinity up to
0.75.
0.75.
Bracket.
Are we including 0.75 or not including it?
Oh, parentheses.
Parenthesis, we are not including it. Okay, any questions on what I did there? Okay, so that's one method. Just, where's the steps? Okay, get 0 on one side, graph it, find the root. And then we're basically looking where the graph is positive, if it's a greater than 0, or negative, like it was in this problem, because it was less than 0. Okay, the second method is just graph both sides of the inequality the way it is. And instead of looking for a root, we're going to look for an intersect. And then once we get that intersect, we're going to look for either where the x's are above that intersect or below it. Okay, so we're going to do the same problem again, except I'll do it with method 2. Okay, graph both sides of that inequality. Don't rearrange anything. Okay, put 4x minus 1 in y1. Put 2 in y2. Okay, so now we know where these graphs cross. Okay, what I'm really looking for is where is 4x minus 1, where is the blue graph, less than 2, the red graph. Okay, where is the blue graph below the red graph? Okay, so what do I need to calculate now that I have that on the screen? Amanda? Yeah, I need to know where they cross. Okay, so that's my intersection, 0.75. And I want to know where the blue one is below, okay, less than. So that's all x's less than 0.75. Okay, so exactly the same answer as the last one. Okay, and which method you use, it doesn't matter. Okay, you can do it either way. Okay, any questions on doing it either calculating a root or calculating an intersect? All right. Okay, so sometimes we have an inequality to solve that it's like a compound inequality, but x is not in the middle. And basically, it's just like solving an equation, except instead of having a left and a right side, you've got a left, right, and a middle. Okay, so whatever we do to the middle, we have to do to the left and the right. Okay, so in that equation up above, to solve it, you divide everything by 2. Okay, all the same rules still apply. If you multiply or divide by a negative, you need to flip the inequality. All right, so let's see if we can solve this one. So we got to get rid of the denominator, the 2 in front of the x, and the plus 5. But we have to do them in the right order. Hey, anybody know what we would do first here to start to get x by itself? Yeah. Quinn?
Multiply all sides by 3.
Yeah, we're going to multiply everything by 3. And by 3. Okay, so on the left, I'm going to get negative 9. On the right, I'm going to get 15. Should I flip my inequality signs? Nope, we didn't multiply by a negative, so we're okay. So keep those exactly the same. And Trevor, what's left in the middle?
6x plus 15. No. Not 2x plus 5.
Yeah, just 2x plus 5. Okay, so at least now we don't have the fraction, okay, in the middle. All right, my next step. Okay, what's the next thing I'd have to do to get x by itself? Well, Jeff? What's our next step?
When you're the plus 5.
Yeah, we're going to get rid of that plus 5. Yep. And how do you do that?
Subtract that.
Yep. So we're going to subtract 5. Just make sure we do it everywhere. Okay, so negative 9 minus 5. How about Rachel? What's good? Negative 14. And again, I'm subtracting, so I don't ever flip when I do subtraction. 5s are gone. And 15 minus 5 gives me 10. Okay, and Amanda, my last step?
Divide by 2.
Yep, divide everything by 2. Am I flipping an inequality this time? Nope, because I'm still dividing by a positive. And I get x is greater than negative 7 and less than or equal to 5. Okay, they didn't ask to write that as an interval, so I'm going to leave it as an inequality. Okay, so any questions on solving an inequality like that? All right. All right, so this one is going to be a rectangle problem. We've done one very similar before, okay, except our answer here is going to be an inequality. Okay? We're not going to be setting up an equation. And when you get to part A, you'll know why it's not an equation. Okay, so it says, think about all the rectangles where the length is 1 unit more than twice the width. Let's start just by writing that down. What am I comparing to here? Am I comparing things to the length, or am I comparing something to the width? Yep.
The width.
I'm comparing something to the width. It's usually the one that's at the end of the sentence. So the one you're comparing to always gets just a variable, and now you write the other one in terms of it. It says my length is 1 more than twice the width. So how would I write that? Ayla?
2w plus 1.
Yeah, 2w plus 1. Now, I'm not sure what they're going to ask me about here. I got to read part A. Is this an area problem, a perimeter? We'll see in a second. Okay, so it says find an algebraic representation of the rectangles above with perimeters less than 100. So I want the perimeter to be less than 100. Okay, what is the perimeter of the rectangle up above? I know its length and we know its width. So what would the perimeter be? Amanda, you thinking about it?
Would it be 2 parentheses 2w plus 1 close parentheses 2w?
And then adding 2w, yes. And can you tell me what that would come out to?
Less than 100.
Yes, true, it would be less than 100. But can you tell me exactly what would be less than 100?
The perimeter?
You're very good, yes, the perimeter. What's the algebraic expression for the perimeter?
Addition?
No, it's what you said earlier, but just all distributed and done out.
Oh, 4w plus 2w.
Yeah.
So 6w plus 2.
Yes, that's my perimeter. Thank you. 6w plus 2. So you got to double your length, double your width, and then add them up. So 4w plus 2 plus 2w. Okay, so find an algebraic representation. We've done it. Now solve it. What could the widths actually be? Okay, so if I solve this, I bring the 2 to the other side. So 6w is less than 98. And Kayla, what's my last step?
Divide by 6.
Divide by 6. And 98 divided by 6 is, I guess let's just round it to 16.3. So the width has to be less than 16.3. Okay, any other restrictions that I might want to be careful with here? What is it?
Can't be negative.
Yeah, I wouldn't leave it just like that. Okay, the width has to be less than 16.3, but it also has to be greater than 0. If you want to combine that into a single inequality, that's fine. But if you forgot to mention the width couldn't be negative, I'd probably take off a point here. Because you've got to make sure it's positive. Okay, any questions on that one? All right, and let's take a look at the last type, which involves absolute values. Okay, so some absolute value ones we'll just do algebraically, and then a couple of them we're going to graph on the calculator because they're a little tricky. Okay, so we talked, I think it was probably beginning of this week, I don't think it was last week, about how to solve absolute value equations. Okay, solving an absolute value inequality is pretty much the same thing. Okay, so absolute value inequalities, okay, first thing you want to do is isolate it, get the absolute value by itself, and then we're going to split it into 2 problems. The first one is exactly like the original, just take out your bars. Okay, does anybody remember from, I think, yeah, it was yesterday, how you get the second one? So the first one, you just take away the bars. What about the second one? Yep, Ayla?
You remove the bars and you negate it.
Yeah, you take away the bars, you change the sign of that number on the other side, you negate it. But what happens when we change the sign of something with an inequality? Like with division or multiplication? Yeah, it also has to flip. So that's the one extra thing. So the second inequality, take the original, get rid of the bars, negate the number on the other side, and you have to flip the sign. Okay, so 3 things. Remove the bars, flip the sign, change the number. Okay, so all of that is pretty similar to solving equations. Okay, the one thing that's a little different with an inequality is your final answer. Okay, Sometimes in the final answer we use the word and. So it's this and this. Sometimes we use the word or. Okay. How do we know which one to use when? Well, if the original problem has a less than or a less than or equal to, you use and. And the way I try to remember, think of it like less than, right? Like less than. Okay? So less than is an and. And greater, think of greater or greater or equal, that's an or. Okay, so greater is an or. Right? And if we're writing it as an inequality, we use these four symbols and an and or an or. If you're doing it as an interval, you don't use the words and or. Okay, you use something that means and or, but it's a symbol. Okay, so if you're writing your answer as an interval, we've seen this one before. Okay, that's a union. Okay, that means or. Or upside down, that's an intersect. Okay, that means and. Okay, so just make sure you're either going to use ands and ors if you've got inequalities. You're going to use intersects and unions if you're writing intervals. Okay, so let's try this one. Okay, absolute value of x minus 3 is less than 3. Okay, Pacey, is the absolute value already by itself here?
Yes.
Yeah. So we don't have to isolate it. Okay, it's already by itself. If it wasn't, then we'd go through that process. So now I'm going to split it. Okay, Molly, can you tell me one of the inequalities that's going to split into?
Oh, what the negative like the absolute part?
Yeah, once we start to solve this, how do we split that up?
Well, like x is less than, right? I'm sure, right? I don't even know. Like x is less than negative 3.
So we gotta do those two things.
Oh, yeah. Hold on. Well, am I doing the first part? The
Mhm.
first one? Okay. Yeah, then we just x minus 3. And then the other one would be x. Would you do? Oh wait, do you still have to put the? Oh, x minus 3 is less than 3.
Yep. So we still need that.
And then the other one would be.
You want to do the other one?
No, I don't want to do the other one.
I was only going to ask you to do one. Anybody else want to do the other one? Yep. Ellen?
X minus 3 is greater than negative 3?
Yeah. Okay, so 3 things she had to do on the second one. She took out the bars, she flipped the sign, and she negated the number. Perfect. Now, should I, just so I don't forget, I like to write down if this is an and or an or. Okay, should this be an and or the or? What word should I put between them? Yeah, look at the original problem, less than, right? Less than is an and. Okay, I'm going to write my answer as an inequality, so I'm going to use and or. I'm not using the other 2 symbols in this one. Okay, so I get x is less than 6. And you have to make sure you put that word in there. X is greater than 0. If you wanted to combine that into a single inequality, that's fine with me. Either write what's on this line, or if you write what's here, you don't have to put the word and because it's invisible. It's part of that conjunction. Okay? Okay, any questions on that one? All right. All right, so this part is a little tricky because what they'll do is they'll give us something in writing, and they'll want us to write it as an inequality. Okay. Basically, if you can remember that formula and just plug in for what they give you, it makes it a little easier. So if x is less than or within a units from b, that's how you can write it as an inequality. So I could say something like, the number I'm thinking of in my head, x, is less than 2 units from 5. So if I said to you, I have a number that's less than 2 units from 5, what that means on your number line, I'm thinking of something within 2 units of the number 5. So I could be thinking of a number as high as 7, or I could be thinking of a number as low as 3. That's how you'd write x is less than 2 units from 5. Right, so this is like saying x is within or less than 4 units of what number is the origin? 0. So all we really have to do is figure out where the 4 gets plugged in and where the 0 gets plugged in up above. Okay, x is less than 4 units from the origin. So just fill in exactly what I wrote under those letters in that inequality, and you'll get what they're looking for. Right? So what would my inequality be? Let's see, how about Trevor?
X minus 0 is less than 4.
Yeah, you could write x minus 0 is less than 4. In this case, since b is 0, you could actually just put absolute value of x is less than 4. Okay? And if you were to solve this, the answer will be all numbers that are within 4 units of the origin. Everything from -4 to +4. Okay, how about this one? X is less than 3 units from 2. Where does the 3 go, and where does the 2 go? Yeah, Molly?
Would it be x minus 2 and then less than 3?
Yeah, x minus 2 is less than 3. Okay, so the part inside the parenthesis, that's what you're away from. The number on the other side is how far away. Okay, so we are up to 3 units away from the number 2. Okay, what are we away from? How far from it are we? Okay, what do you think would happen if it said x is more than 3 units away from 2? What would change in that inequality? Yeah, it would change to a greater than sign. Okay. All right, and the last couple we'll do these on the calculator. Actually, this one. Does anybody need me to do this one? Example 10 is almost the same thing as example 8. What's the only difference between example 8 and example 10? The big difference, yeah?
Example 10 with the greater than sign.
That's a greater than sign, so my final answer is going to have what?
Or.
It's going to have an or. Okay, so when you're done, it would be one answer or the other. All right, so let's solve. Let's see, we have 11 and 12. Let's do 12 on the graphing calculator. I think that one's a little more interesting. Okay, this one already has 0 on one side, so I don't have to rearrange anything. So I'm just going to type it in the way it is. And once I create my graph, I'm going to look for where it's positive. Okay, look for where it is greater than 0. What do I need when I type this in? Gotta be careful. It's not written on paper, but I need it on the calculator. Yeah, I want to make sure I put parentheses. So parentheses x plus 3 divided by, does anyone remember where I get absolute value from? Yep, it's under math. It's in the number column, and it's the first one. Okay, so absolute value, I don't need parentheses because those brackets act like parentheses. Okay, what number is not in the domain here? Negative. We might get some negative numbers in the domain. I mean, actually, yeah, there's lots of negative numbers you can use, but there's one number you cannot use in the domain. 2. Okay? 2 is the only number that cannot be used in the domain. So something weird is going to happen when the graph tries to cross 2 on the screen. Okay, those are not connected. Okay, those are 2 disconnected pieces. And I want to know where my graph is above 0. Okay, let's look at the left section. Okay, is there anywhere on the left section where the graph goes above 0? From where? Or how would I figure out from where? What do I need to know about something on that left section? I want to know exactly where it's above 0. Yeah, I have to find the root. Okay, find, it looks like it's at -3. I can confirm to you it is -3 because I plug -3 into the numerator. I will get 0. But if you weren't sure, calculate the root. So do I want to include -3 or don't include it? Yeah. So I'm not going to include it. And I can go from -3 up to what number on the x-axis? 2. Okay, we have to be careful. We don't include 2 because that is not in the domain. So from -3 up to but not including 2 covers all of that. Is there anywhere else my graph is above 0? What do you think? Anywhere else? Yeah. So if it's going to be above 0 somewhere else, we need an or. Okay? We could either be in that section that I highlighted in red, or where is this interval going to start at but not include? 2. Okay, it's going to start at 2. And now the only question is, does this graph ever come back down below 0? So what could I plug in into my table to see how low this section is going to go? Andrew, what would be a good x value to check? 900? 900? All right, that's pretty big. So does it look like it's approaching a value but probably never going to reach it? What does it look like it's approaching? 1. Okay, you could try something even bigger. Okay, it's getting very, very close to 1, but it's never going to reach it. So this right section, we can include the whole thing forever. So it's from 2 up to what? Yeah, from 2 to infinity. Okay. That one would be a little tricky to do by hand, so that's why we can solve it on the calculator. We did a lot of them algebraically, so I wanted to do it graphically. Okay, so any questions on that? So you can always use the calculator to double check your answers, see if you're right. But if the directions on the test specifically say to solve algebraically and you do it graphically, you won't get any credit for it. So you do have to make sure you know how to do something like example 8 and 10. Okay. All right, so the homework tonight is page 108. And there's no big stretches of problems, but it kind of skips around a lot. So it's 5 through 7, 10 and 11, 14 through 16, 19, 20, 22, 24 to 26, 29, and then on 34 to 38, just the evens. Okay, you don't do all of them. And then 42, 43, 49, and 60 through 62. Okay, some of these little stretches, like 24, 25, and 26, I think they're all the same problem, kind of like the break-even one last night. So it's like you do one part and then the next part, and it leads you to the final part. Okay, so we'll take a look at that tomorrow. Don't forget progress reports on Friday, so anything that you need to get to me, it's got to be made up by Friday, okay, or that will become a 0. And I will be after school on Thursday.